Okay guys, today we're going to talk about 7.3 rational exponents. So we've been dealing with integer exponents, and now we're going to talk about rational. So you might say, well, what exactly are those? So let's give it a little definition. Rational exponents. And that is an exponent that is a fraction. Okay, so we're going to go through some stuff that might be a little bit mind-bending, but we're going to get through this together. So let's start with an example. Let's do b exponent of 2. We read that as b squared. Okay, now if I took that b squared and I took the square root of it, so this would be called the square root of b squared. What I'm looking for is if I took a number and multiplied it by itself, I'd get b squared. What is that number? So what I'm going to do is share with you something interesting about radicals. Okay, so let's investigate this square root symbol. So this is called a radical. Now, this radical has a little crook. It's not a division symbol. It has a little crook. And I'm going to just draw a little arrow into this crook. And in there would be the index. They call it an index, the number. Now, if you don't see a number, the index is 2. That's what makes it a square root. It's that it has an index of 2. Okay? So that's the square root. It has an index of 2. So let me write that down. Okay. Now, we call that a radical is the whole thing. We can call just the symbol a radical sign, but I'm going to put something inside and we'll call it x. He is called a radicand. Okay, so the radicand is the guy that's under the radical symbol. All right, so what's the exponent on the x? Remember, if I don't see one, it's a 1. So, stick with me here. This is going to be mind-blowing. So, what I can do is I can take that radical, I can take the square root of x, and I can get this. So, I'm going to get x, and now I'm going to write the exponent, the radical, as an exponent that's a fraction. We're going to take the coefficient, the root on the radicand, the x, and that's our numerator. We're going to take the index, or what kind of root we're taking our number to, which we said was 2, and that's our denominator. So taking a square root is the same as taking a number to the half power. Okay? Mind-blowing, I know. So if we go back to our b squared idea, and we take the square root of it, we're basically going to take b squared, and we're going to raise it to the 1/2 power. So when I multiply my radicals, or my exponent, I have 2 times 1/2. That's going to give me b to the 1st power, or simply b. Okay? So that is the idea of a rational exponent, is to take a radical and write the exponent as a fraction. okay? Because that allows me to do a lot of things with math. So just a statement here, squaring, so squaring anything is the inverse of taking a square root. Okay, so this isn't just applied to square roots where the index is a 2, it applies to any kind of root. So let me show you a cube root. Cube root, once it's not a square root, where the index is 2, and nobody has to write that 2 there, every other index has to be included, otherwise it's just going to be a square root. So if I say I've got an index of 3, I would read this as the cube root of 3. Or cube root of x. Let me try that again. Okay, cube root of x. Okay. So, how would I write that with a rational exponent? Okay, so remember, what is the exponent on the x? It's a 1. So if I wanted to write the cube root of x with a rational or fractional exponent, I would put the exponent from that radicand on top, and the index would go in the denominator. So the cube root of x would be the same thing as x to the 1/3 power. Okay? All right. What if I still have a cube root and I still have an x, but instead of the exponent being a 1, the exponent is a 2. Okay, so what is that going to give me? Well, if I write it as a rational exponent, I'm going to take that 2 and it's going to go in the numerator, and the denominator is the index, 3. So the cube root of x squared is the same thing as x to the 2/3 power. Okay, so overall, the numerator that's going to be the exponent on the radicand. Okay, and the denominator is going to be the index of the radical. So the index of the radical, or we could say it this way. Oops, sorry, radical. We could also call it the root. What root are we taking it to? So the root value. So we're taking it to the 3rd root. Okay. All right, so let me show you. So again, this whole chapter so far has been about mental math gymnastics, okay? It's just all sorts of multiplying and adding and subtracting and, yeah, powers to powers and so on and so forth. All right, so let me give you an example with some other numbers. Let's say I want to take the cube root of 64. Well, the problem is there's only one 64. And in order for me to take a cube root, I got to have 3 of the same things. Remember when I had a square, b squared, and I wanted to take the square root? I got out the b. Why? Because when I multiplied the exponent on the radicand, the 2, by the radical written as a fraction, 1/2, I ended up getting an exponent of 1. on my B. So let's think about it. Let's see, 64 is 4 times 16, and then we have 4 times 4. Now, so I would stop there. As soon as I have 3 of the same factor, I would stop, okay? So then basically what this is going to give me is 4. So I'm going to pull that base out. Exponent on the base, on the radicand, is going to be 3. And it's going to get divided by the index number, which is a 3. So that gives me 4 to the first power. Okay, let's say I have 3 to the, and I want to take the cube root of 2 to the 6th power. So again, I'm going to take that exponent on the radicand, and that becomes the numerator. The index, what kind of root I'm taking it to, the root value is going to go in the denominator. Now let's see, 6 divided by 3 is 2, and then I squared 2, and I get 4. Okay, so it's a way to deal with things I can't normally deal with. All right, let's go to the next screen, and we've got to do some examples. So the directions are going to say, write in radical form, or in exponential form. Okay, so if they give me a base with a fractional exponent, I'm going to change it into radical form. Okay, if they give it to me in radical form, then I'm going to change it into exponential form. So let's say this guy would be something like that. Okay, so that's what we're going to play with here. So I'm going to do the direction that meets the problem. So the form it's not in is the form we're going to change it into. So I have a to the 1/2 power. Okay, so I know a is going to be under the radical sign. I have 1a, so because I have 1a, or a to the first power, I don't need to write that exponent. And because the denominator is a 2, what that's telling me is to just write the square root symbol, because that is what square root comes from, is the number 2. So the index is 2, and I don't need to show it. So actually, that's it. I'm done. So that's the answer. Okay, let's try another one. Square root of 22. Okay, so this is saying now I want you to write this using exponents. Okay, so we write the base, the radicand. On the radicand, I did not see an exponent, so that means it's 1. And I don't see a number in the index, so that means it's 2. So this is the same thing as 22 to the 1/2 power. Okay? All right, next one. Let's see, we've got the quantity 7w, and I want to raise it to the 1/2 power. Now, because of the parentheses, it says everything in the parentheses is being raised to the 1/2 power. But remember what a 1/2 power means. It means I'm going to have 1 of that 7w as the radical, and the index is 2. Because the index is 2, I leave it as is. So I'm taking the square root of 7w. Okay, let's try another one. We have 2 times the square root of x. So since I have a radical, I need to turn it into exponents. So I have 2, he's on the outside, I have the x, and it's the x that's going to get the exponent. So there's 1x, and the index is 2. So that would be my answer, 2x to the 1/2 power. Okay, now we have another set of directions, and we'll be done. And the directions are going to say simplify it. That means do all the math that you can do until there's no more math to be done. So we've got 5, number 5, we have 8 to the 1/3 power. Okay, so first thing I'm going to do is I'm going to write this in radical form. Okay, so I have 1/8, and it's to the cube root, so the index is 3. But then I got to figure out how to change 8 into a number where I have 3 of them. So if I do some prime factorization, I get the cube root of 2 cubed. Okay, so now if I change this from radical back to fractional or exponential, exponent form, the radicand is 2. It had an exponent of 3, and it's going to be over the index of 3. And 3 divided by 3 is 1, so I end up just with the answer of 2. So, just to remind you, the exponent rules, so that's for multiplication and division, anything we've learned so far, apply to rational exponents. So the same things that happen with regular exponents happens with rational exponents as well. Okay, and we'll explore more of that at another time.